In this video, we're going to talk about equivalent fractions. Let's start by looking at some pattern blocks.
Here we're using an area model. Let's say that our reference whole is the hexagon. Let's start by dividing the hexagon into 3 equal parts. Here, one blue rhombus is 1/3 of the hexagon. We could also partition the hexagon into 6 equal parts using the green triangles. I can see in this case that 2 parts, each worth 1/3 of a hexagon, is going to be the same as 4 parts, each worth 1/6 of a hexagon. I can overlap them and see that 2/3 of the hexagon is the same quantity as 4/6 of the hexagon. When working with equivalent fractions, it's really important to be mindful that we're dealing with the same whole, especially as we draw visual representations. For example, if I took 2/3 of a medium pizza, and then I took 4/6 of a large pizza, these would not be equivalent quantities. Doing an approximation of my thirds and my sixths, I can shade in the 2/3 and shade in the 4/6 and clearly see that these do not represent the same quantity. So in this case, 2/3 is not equivalent to 4/6 because we have a different reference whole. Let's take a look at an algorithm for finding equivalent fractions. I'll draw a rectangle, divide it into 4 equal parts, and then shade 3 of them to show 3/4 of the rectangle. One way to find an equivalent fraction is to multiply the numerator and the denominator by the same value. Let's multiply both by 3. Now I have 3 times as many parts. I kept the reference whole the same size, and so that means my parts have to be smaller. Because I have 12 parts now, the reference whole divided into 12 parts, I have 3 times as many shaded parts as well. Now I have 9/12, and you can see that the 2 pictures represent the same quantity. It would have been a mistake to represent 3/4 like this, and then when I multiplied the numerator and denominator by 3 to expand the reference whole to get 12 parts, because these wouldn't represent the same quantity. Now let's look at a linear model. This number line, the 1 unit, has been divided into 12 equal spaces, and so we can label them as 12ths. Where 12/12 is equivalent to 1. We didn't have to partition the 1 unit into 12 parts. We could have partitioned it differently. We could have partitioned it into 3 equal parts. And if we have 3 equal parts, then our denominator will be 3. This will be the first of 3 parts. And then we'll have 2 parts, each worth 1/3. And then we'll have 3 parts, each worth 1/3. So from that we can see that we have equivalent fractions. Here, 1/3 is equivalent to 4/12, and 2/3 is equivalent to 8/12.